Okay, hi. So we're doing module 2 of switching routing with wireless essentials, and so it's switching concepts. So we're going to look at frame forwarding and switching domains. So we'll look at collision domains and broadcast domains. Okay, so frame forwarding. So switching and networking. So two terms associated with frames entering and leaving a switch is ingress, or entering an interface, or egress, which is exiting an interface. So a switch forwards frames based on the ingress interface and the destination MAC address. A switch uses its MAC address table to make forwarding decisions. Note the switch will never allow traffic to be forwarded out the interface it received from traffic on. So here we've got an example switch. It's got 6 ports, and very short MAC addresses, but anyway. And so we've got some destination addresses there and what ports they're connected to. And so basically, when a frame arrives at the destination of PA, we will look up this table and go, all right, that needs to be forwarded out of port 3. And so that's basically how it works. Now, switch address table. A switch will use the destination MAC address to determine the egress interface. Before a switch can make this decision, it must learn what interface the destination is located. A switch builds a MAC address table, also known as a content addressable memory, CAM table, by recording the source MAC address into the table along with the port it was received on. So basically, every frame that it sees, yes, it will use the destination MAC address to forward it, but it will also use the source MAC address and the port that frame arrived on to update its MAC address table, basically. So that's the two major things that happen when a frame arrives at a switch port. So basically, the switch uses a 2-step process, and so it learns addresses by examining source addresses, as I said, as the source MAC address if it's not already in the table, and it will normally have a 5-minute life in that table. If it sees a frame for an entry it already has, it will basically reset that timer back to 0, so it has another 5 minutes. And so, of course, it will forward frame based on the destination MAC address. And so if the destination MAC address is in the table, it will be forwarded out that port that's specified in the table. If the destination MAC is not in the table, it is actually flooded out all interfaces except for the one it arrived on. And so forwarding and flooding are the major options. So switches use software on application-specific integrated circuits, or ASICs, to make very quick decisions. A switch will use one of 2 methods to make forwarding decisions after it receives a frame. So there's store and forward or cut-through switching. So store and forward switching is a more traditional way. It receives the entire frame, ensures the frame is valid, so in other words, actually does the full chain frame check sequence, and then it will then look up the destination MAC address and then start forwarding the frame. Another one is cut-through switching, and so forwards the frame immediately after determining the destination MAC address. So actually the first field in the header for a frame is actually the destination MAC address, so that minimizes the amount of latency that switches cause. Now, so Cisco says store and forward is its preferred switching method, but I think cut-through is the default, but anyway. All right, so store and forward, as we said, it does the error checking, which is good, and so it doesn't forward frames that have errors in them. Of course, frames with errors are pretty rare. And so the ingress interface will buffer the frame while it checks that frame check sequence. This also allows the switch to adjust the potential different speeds between ingress and egress ports. So if it's arriving on a fast Ethernet port but needs to go out a gigabit Ethernet port, it will certainly need to buffer it because, yeah, you can't send it at gigabit speed if it's only arriving at fast Ethernet speed, so it's got to wait for the whole frame to arrive. Now we'll cut through, forwards the frame immediately after determining the destination MAC address. And so that is, yeah, as I said, basically the minimum latency. As you can see here, it just waits for the preamble and then the MAC address to arrive, and then it looks up the table and it forwards the frame. So it's not very, it's pretty much as quick as you can get with Ethernet. Now, there is sort of, so basically there is a compromise between the two, between cut-through and store and forward, and it's called fragment-free, and that method will check the destination and ensure that the frame is at least 64 bytes in size, and also, if there are any errors or things like that, they should happen in the first 64 bytes of the frame. And so that's sort of a compromise between the two. Now, cut-through switching is appropriate for switches needing latency under 10 microseconds. It does not check the frame check sequence, so it can propagate errors, but they're pretty rare these days. May lead to bandwidth issues if the switch propagates too many errors. Cannot support ports with differing speeds going from ingress to egress. And so you have to buffer when the ports are differing speeds. So, switching domains. So, basically, collision domains, switches eliminate collision domains and reduce congestion. Where there is a full duplex in the link, the collision domains are eliminated. When there is one or more devices in half duplex, there will now be a collision domain. And so there will now be contention for the bandwidth, and collisions are now possible. Most devices, including Cisco and Microsoft, use auto negotiation as a default setting for speed, duplex, and several other settings. Now, full duplex basically turns off collision detection because they're not possible. And so, you can transmit and receive at the same time, works beautifully. But half duplex, it's much the same as what the Southern Expressway used to be. Now, in the mornings you could go to town, and then in the evenings you could go home from town. And so basically it was two directions, but only one at a time. And so if there is traffic going in both directions, it means you've had a collision, you've got errors. So normally, if there's half duplex, you would normally assume there's a switch somewhere abouts. And so, of course, collisions are an issue. Did I say switch? I mean hub. There's a hub about, so collisions do become an issue on hubs. All right, now, switches basically can be a border for collision domains. And so, as we said, if you've got full duplex, switches will basically get rid of the collision domains. Broadcast domain switches don't do a lot about.
Okay, so a broadcast domain extends across a layer 1 or layer 2 devices on a LAN. Only a layer 3 device, like a router, will break the broadcast domain, also known as a MAC broadcast domain. The broadcast domain consists of all devices on the LAN that receive broadcast traffic. When the layer 2 switch receives a broadcast, it will flood it out all interfaces except for the ingress interface. Too many broadcasts may cause congestion and poor network performance. Increasing devices at layer 1 or layer 2 will cause a broadcast domain to expand. So basically, all hosts on a subnet will see a broadcast, and so basically it's a router interface that, of course, is the boundary between subnets, and so it's a router that stops broadcasts. So how do we alleviate network congestion? So switches use a MAC address table and full duplex to eliminate collisions and avoid congestion. Features of the switch that alleviate congestion are as follows. So fast port speeds. Depending on the model, switches may have up to 100 gigabits port speeds. Fast internal switching. This uses fast internal bus or shared memory to improve performance. Large frame buffers. This allows for temporary storage while processing large quantities of frames. And high port density. This provides many ports for devices to be connected to the LAN with less cost. This also provides for more local traffic with less congestion. Okay, so we've just about hit the end of the chapter. And so we've looked at frame forwarding. So, of course, ingress is the entry port, egress is the exit port. Switch builds a MAC address table to forward frames on the LAN. The switch can use either store and forward or cut-through method for switch forwarding. Switching domains, Ethernet ports in half duplex will be a part of the collision domain. Full duplex will eliminate collision domains. A switch will flood out all interfaces except the ingress port if the frame is a broadcast or if a unicast destination MAC address is unknown. Broadcast domains may be broken up by a layer 3 device like a router. Switches extend broadcast domains but can eliminate collision domains and relieve congestion. So they're not an all-in-one fix, but they are a good fix. And so that's the logo. That's it for chapter 2. And so we'll get back to you with chapter 3 at a later date. Have a good one.